Hello, AAA students. This is a recorded lesson that you need to watch for tomorrow's class, so thank you for doing so that you're prepared. This is talking about using rational numbers as exponents, and we have kind of talked about this a little bit, so it should be a pretty easy lesson, but I just want to make sure that we really formalize what we have discussed so far. So understand, these are the things up at the top in the box. You should have your notes page in front of you from your packet, okay, so for lesson 7.5. And so this video lesson will follow along with that notes page. So notice in the box up at the top, it says if you are talking about positive numbers and zero, taking a power and then a root is the same thing as taking a root and then a power. So symbolically, the way that we would write that is to say that the kth root of something to, say, the m power is the same thing as if we were to first do the root, then after that do the power. So what I was thinking of on the left is taking the power first and then the root. Over here I'm thinking of taking the root first and then the power. So you have flexibility. The way that you're going to decide which one to do is depending on what numbers you have and what would be the easiest. We want to go easy, all right? We also have talked about this already. We know that if we are taking the kth root of a quantity, that is the same as doing a to the 1 over k. And if you already have an exponent, so say you have the kth root of a to the m, that's going to be a to the m over k. And we had a little discussion about how that student I had a while back told me this thing about trees. And she said that at the bottom of trees you have roots. And so the thing that is the root is going to be at the bottom of this fraction. Same thing here. The thing that's the root is the bottom of the fractional exponent. That's a cute little way to remember it. Not very mathy, but cute. And the last thing is that negative exponents are defined just like they were previously, meaning that if they are negative exponents in the numerator, they're going to become positive exponents in the denominator, and vice versa. So if I have something to a negative exponent, even though that exponent is a fraction, the rule works the same. This amount here, this expression is in the numerator, so we can put it in the denominator, and the fraction is what becomes positive. Okay, so notice that it's the negative that dropped here to make it be something that I would express without a negative exponent. Okay? Sorry my writing is so bad on this slate. Okay, so we'll just do the best we can, right guys? Alright, throughout these examples, I would like you to assume that all variables are positive. So we're not even going to deal with absolute value rules from this point on. We have talked about that quite a bit. And so in the second half of the chapter, we're just going to assume our variables are greater than or equal to 0, so we don't have to deal with absolute value signs anymore. So the times when we will have to deal with absolute value signs are when we don't have this proviso, right? Okay? Just so you're aware. All right, so here's our first example, and we want to think about the different rules that we had at the top of our page. And this one is an example where I have a power and a root. And so I want to think now, which way would it be easier for me to think about? And probably it's going to be easier for me to think about having the cube root of 8 twice. Right? So I'm thinking of the root first and then the exponent. So cube root of 8 squared. Okay, what is the cube root of 8? Hopefully you wrote down a 2. So 2 times 2, or 2 squared, is equal to 4. That's going to be our first thing. Okay? Second example, we want to think about, well, what's going to be more advantageous? I think in this case it's going to be more to our advantage to think about that cubing first. Cubing means I have 3 copies of something, and I'm going to write this as 2 copies and then 1 more. Do you see why it was helpful to do this part? That part has an index of 2 and an exponent of 2, so those things cancel out, and I just have 5x and then the square root of 5x. Okay, our next example, I think it's going to be more advantageous in this one to do all of our squaring first. So I'm going to think of the cube root as being something I just hold on to for a while, and I'm going to square all the things that are inside. So that would be 81, x to the fourth, y to the second, and then I can think about if any of these are perfect cubes. So I do have a perfect cube. Inside that 81, there's a factor of 27, and then a cube root of 3 would be left. And then there's going to be a group of 3 for the x's, with an additional x left over. And I don't think we're going to be able to do anything with those y's, so I'm just going to leave those right there. And now in my next step, that first piece is a 3 on the outside. That part, second part is going to stay in. This part can come outside the radical. This part's going to stay in, and that part's going to stay in. So inside my cube root are the things that are not perfect cubes, nor do they contain perfect cubes. A 3, an x, and a y squared. And that's it. Okay, on our next example, it's going to be most advantageous to think about having 9 to the second and another 9. This is a lot like question 2 was. And this first term here, this first part, has a square and a square root. So that's just going to be 9, square root of 9. Wait a second. Square root of 9, you can do more with that. I almost left that. Did you hear that in my voice? Okay, square root of 9 is 3. You get 27. Holy cow, I can't believe I did that. Must be the time change still, having its influence. Okay, the next one, let's think. How else can I write a fractional exponent? A fractional exponent can also be written as a radical. So let's see if that helps us. Square root of 7. Yeah, I think that's it. There's nothing else that can be done with that, so we'll just let that sit. Okay? Over here, I think it would be nice to rewrite the 25 as 5 to the second, and then I already have another exponent of 2. So this would really be the fourth root of 5 to the fourth. But that's not the only way we could have approached that, but I thought that was a pretty nice way, and I didn't have to touch my calculator or think about anything else, because now I can see that the index and the power match, and so the answer here is going to be a 5. All right, couple more to go, guys, and then we're done. All right, this next guy, I think what I'm going to think about for number 7 is this idea. The idea that if I have a power and a root, I can write that as a fractional exponent. Look at how nice this is going to be. We're going to write this as 2 to the 12 sixth power and a to the 6 over 6 power. These 6's in the denominators came from that. That's a root. Remember, roots go on the bottom. So really what we have is 2, and then 12 divided by 6 is 2, and then a, and then 6 divided by 6 is 1. 2 squared is 4, and then I have an a, 4a. Oh, that's nice and simple. Okay. The next one, I'm going to make use of this property, that if I have a negative fractional exponent, I can put that entire expression, the whole thing, in the denominator. It makes the exponent positive. So this is 1 over 8 to the positive 1/3. And I know that to the 1/3 can also be written with a radical, a cube root. And I think you should know the cube root of 8 by now. It is 2. So this entire expression equals 1/2. And our very last example for tonight is this one, and it has a negative exponent, but it's already in the denominator. So we're going to move this entire expression to the numerator and make that fraction positive. So now I'm going to think of this as the fourth root of 16 to the third. I want to think about, is it better to do the fourth root first or the cubing first? I think it's better to do the fourth root first, because that comes out pretty good, I think. Comes out well, I should say. The 4th root of 16 is 2. And 2 to the 3rd is 8. And so that was easier to do than to try to get my calculator and figure out what 16 to the 3rd is. All right, so that completes our notes. You have some practice problems to do tomorrow, but we'll do those in class together. So you are now done with your homework. Thank you for listening to this lesson.